Good evening, everyone. Thank you very much for your attendance here. It's great to see you all. I'm George. I'm one of the partners here at Hambro Perks. I'm not going to talk very long. All I wanted to do was just to welcome you and say thank you very much for coming. Plenty of familiar faces in the room. But for those who don't know us and don't know what we do, we're a venture firm focused on building European technology companies. We do that both investing through primary vehicles and also we have a secondary fund as well. And our focus is really trying to stay relevant to companies from the beginning to the end of their life. So from a piece of paper all the way to, broad sun uplands and billions of dollars and IPOs and all of that good stuff. One of the areas that we're really interested in focused on, unsurprisingly, is AI and machine learning. So tonight's really about digging into that in a little bit of detail and really thinking about what does that actually mean practically, because there's a lot of noise about it. There's a lot of very educated people in this room who understand that there's a great deal more subtlety and depth to some of what's written about it. So the goal is that we should get into it with some detail, with some people who really know. So that's really everything I wanted to say, except please stay after for drinks. And I just wanted to introduce Mathilde, who's going to lead us through. So Matty is a principal on the investment team here at Hambro Perks. She's very focused on AI and ML businesses for us. And before she joined, she built a startup called Compass News, which was focused on machine learning in the media space that we actually backed as a firm. We thought she was so great that after that we hired her. So without further ado, I'll hand over to Mathilde and the rest of the panel. Thank you very much.
Thank you so much, George. Thanks, George. Thank you so much to all of you for coming along. We really wanted to do an event on AI because we feel that while AI interest is really booming, there is still a lot of confusion on what AI actually is. What's certain is that there is a lot of opportunity, but also a lot of hype. So we really hope that by the end of this event, we'll be able to distinguish a little bit more between the two. In order to do that, we're actually going to break down AI from all perspectives. Each one of us is going to do a very short presentation, 10 minutes, on different topics, and then we'll open up for Q&A. In terms of topics, I'm going to talk about how we invest in AI companies and which are the things that we look for in AI companies. Alessandro is going to tell us about the technology and the latest trends and which are the things that are working and not working. Charlie is going to tell us about how corporates are actually adapting to this new technology. And then Tim is going to tell us about what it actually means to build a machine learning startup. I'm super excited to be with this amazing panel. I've been working with Alessandro and Charlie for many years, and I'm really happy that now they're part of the Hambro Perks family. And obviously super delighted to have Tim as well, who's the founder of an amazing company that we backed called Care. And actually, now it makes sense for you guys maybe to do a very short intro on who you are, conscious of the fact that there is a bio behind you. But
Hi everybody, I'm Alessandro Ialongo. I'm a PhD researcher at Cambridge and the Max Planck Institute. And I've also spent time in industrial labs at Google DeepMind and Prowler in Cambridge.
And I'm Charlie from the LSE. I spent 2 decades working as a journalist for people like the BBC and ITN's Channel 4 News. I spent the last 15 years at London School of Economics. I'm a prof in the Media and Communications Department, but my main role is I run something called Polis, which is the LSE's journalism think tank, and most recently I've been doing a huge piece of work, in fact still going on, a huge piece of work looking at journalism and AI.
Hey everyone, I'm Tim Porter. I'm founder of Care. I'll talk a little bit about what Care does in a minute, but in terms of my background, I spent about 20 years in technology. I was at a company called Shazam when it first launched, or just a little bit before it launched, and then I was at Apple for about 6 years, around the early days of iTunes, and I was at Google, working on Google Play and Mountain View for a little while as well.
Great. So you already know about me, so I'm going to just start. I'm going to talk about how we invest in AI companies and which are the things that we really look for in AI companies. But before we get into that, it probably makes sense to actually tell you about how we think about AI in the first place and really address the big elephant in the room, which is that AI actually doesn't exist. We are so far away from achieving AGI, so artificial general intelligence, and for computers to really think like human beings. What we do have, though, is machine learning, and machine learning is a subset of artificial intelligence. Obviously, there are a lot of ways to describe machine learning and definitions out there, but the definition that we use internally is computer programs which are able to perform a very defined task based on training data. And obviously, they can do this faster, more efficiently, and just cheaper and at a scale that was completely impossible before. And this is why machine learning companies are already revolutionizing so many sectors. And they do this in different ways. So this is how we categorize machine learning companies internally. We distinguish between horizontal and vertical use cases. Horizontal use cases are companies which design products that basically are applicable to many industries. A very good example of that is a CRM like Salesforce. Vertical use cases are companies which design products that are actually just applicable to one industry, let's say software for autonomous vehicles. The second one, quite straightforward, enterprise versus consumers, so companies that target enterprise customers and companies that target consumers directly. And then third one, platforms versus tools. So companies that are trying to control the underlying layer of artificial intelligence and companies that are building tools on top of that layer. So where do we stand? Well, we are really excited and more excited by companies that go vertical. And the reason for that is because we think that machine learning is actually built to go vertical. Models need to recognize a very specific set of signal data from a very noisy, massive data set. So in order for you to increase accuracy, you actually need to see a very specific data that is always the same and it is relevant to the problem that you're trying to solve. Second, we prefer companies that target enterprise customers. And this is because, if you think about the biggest companies on earth, Google, Amazon, Apple, like you name it, they are all trying to address massive consumer problems, and they have all the data in the world to do it really, really well. So competition on the consumer side is really strong and difficult. And lastly, we really like companies that start as tools and then develop as platforms. So really startups that can really address an entire business problem, from how to get the data to how to build a loop to learn from the data, and ultimately how to build a user experience that is really addressing that specific problem. There are a lot of trends that we're seeing recently with machine learning startups. There are 4 that we're super excited about. The first one is basically companies that are building entirely new products and services. The second one is companies that are building applications to perform tasks more efficiently and complete tasks more rapidly. The third one is companies that basically are solving problems that were completely impossible to solve before, or at least with the same time and the same level of resources. And lastly, and this is personally the one that I think is more exciting, is companies that are basically making the market bigger. And by this we mean AI obviously makes serving a mass audience so much cheaper, and so it makes it possible for people, for a mass audience, to enjoy premium products and expensive products that before were completely unaffordable. Really good example of that is 24/7 security guards. So obviously it would cost you a ton of money to have a security guard in front of your building 24/7, but with computer vision you can do much of the controlling with a machine, and then obviously the service itself becomes so much cheaper. While we are absolutely excited by machine learning companies, we also think that there are big challenges that are unique to them. So the first thing to realize is actually that the unit economics for machine learning companies just aren't the same as software companies. And sometimes they resemble more traditional service businesses. For example, they have low margins. So anecdotally, we've seen internally that the gross margins for machine learning startups are between 50 and 60%, versus the margins for, let's say, a SaaS play, which can go from 70 to 80%. The reason why there is this difference in margins is primarily because of 2 reasons. The first one is the fact that there is a hidden cost in the infrastructure, in the cloud infrastructure, so it costs thousands of pounds just to build one model. And the second one is that often you have humans in the loop. So you often need human beings to actually manually labeling the dataset to make the dataset quite relevant and useful. So these 2 things really put up the cost of serving that product that you're building. Second thing, and this is probably the most controversial point that I'm going to make tonight, but I really believe in it, is that the tech in and of itself is not a way that you can make defensible your product. And this is because most of the innovation is actually coming from academia and it comes open source. So it's really hard to build a defensible product just based on your data, on your tech. So what do we look for in machine learning companies? Well, we look for different things than those that we look for in software companies. The first one is the problem. So obviously, is this problem big enough that is worth addressing? But also, is this problem best suited for a machine learning solution? So machine learning is optimization. So you can potentially optimize so many things in businesses, and you probably should. But this doesn't mean that you are building a machine learning company. Second, go to market. So for machine learning startups to actually sell to enterprises is brutal. And there are millions of reasons for it. Really happy to address that during the Q&A. But basically what we look for is companies whose product is so outstandingly great that they can demand a price that is high enough to enable them to do the go-to-market and sales motion. Third one, which is the most important thing of all, is proprietary data set. You need a proprietary data set and access to a unique data set to actually have better results than those that could be achieved with, let's say, commodity data. Fourth one, linked to the third one, is data-driven network effects, which basically means the more users use your product, the more data they contribute, the better your product becomes. And lastly, because tech isn't all to build a defensible product, we actually look for things like how do you deploy the product and execution. Lastly, I think it's worth mentioning that even the due diligence really changes when we're talking about machine learning companies in comparison to software companies. Because we really look at the data set heavily, and we ask ourselves questions like how accessible this data set is and how easy it is to replicate it, how big is the data set, and do you have enough of it to basically replicate reality and predict reality. And third one, how fresh is this data set, right? This is specifically important for some verticals like financial markets where things change all the time. So you need access to live data to actually be able to predict what's happening next. So that's it. I hope this gives you an overview of how we invest in AI companies, what are the things that we look for in AI companies, and why we think AI companies are different. Now I'll leave it to Ale that will tell you a little bit more about the tech and new trends.
Thank you, Matti. So first of all, I should say that I was actually surprised when Matti asked me to speak here, because we constantly speak about machine learning and I'm always complaining about nothing works, everything is a failure, the stuff that the community cares about is not useful in the real world. So given that I am here, though, I've been trying to give credit where credit's due, and actually there have been a lot of successes. So I'm going to talk about why these successes have been possible, and maybe also, though, at the end, you'll have to indulge me and let me speak about the stuff that still doesn't work, which is the stuff that obviously the science community cares about more. So you probably have seen a lot of success cases. So images is probably the one that's been around for the longest. We've got great semantic segmentation systems that can tell you what things in an image are. They're useful now for the perception side of autonomous vehicles, for instance. You can do text annotation of images. And images have really been, since the 90s and the invention of some kind of architectures that we'll look into, they've been one of the first early success stories for kind of the new age of machine learning and neural networks in particular. But also audio, and this is work from DeepMind more recently, looking at raw waveforms and processing them using neural networks again and going text-to-speech. That's also been a sort of more recent success of machine learning and deep learning. And of course, language, you will have seen, we've got very powerful translation systems that are based on sequence-to-sequence models that are based on very sort of large engineering efforts and huge databases, but now can give you something that is pretty good, I would say. And of course, we should also stress that now we've reached a level of maturity thanks also to the appearance also of very flexible and powerful tools and code frameworks that allow you to have automatic differentiation and kind of speed up a lot of the iteration that was very painful only 20 years ago. And now an engineer with no background in mathematics or machine learning can effectively pick up how to use these models and implement them in an afternoon if they want to. Okay, so now I want to talk a little bit more about what are the very basic things in the machine learning toolkit that have enabled it to have bring about some of these successes. And they're going to be very simple operations. So, for instance, one thing, and this goes back to the images, is the convolution. this has turned out to be hugely successful for images, and it's very simple. So you have an input image, which is basically just a grid of pixels, and you apply patches in a sort of sequential fashion, going through it and traversing it, and each one of these operations gets fed forward to a higher level image, which is just a summary of what is going below. So you can think of that the blue square, the dark blue square that's moving around, is trying to detect things like edges or faces and stuff like that, and then it's activating neurons at the layer above that's going higher up in representation, in abstraction. And this is useful because, for images in particular, because you kind of have a local structure in images, right? You sort of, to recognize a face, you'll first maybe start from a nose or something small, an edge, and then move higher and higher up in abstraction to actually detect the things that are in the image. And one example here is that if you do the sort of the reverse exercise of thinking what is it that excites these neurons the most, you'll generate patterns like this one, and you can probably guess that this part of the network is basically excited to see elephants. So it's been trained on a lot of elephant data images, and it's now picked up what it means to be an elephant to some extent. And you can kind of see that it doesn't really generate an elephant at the whole macro level. It just generates parts of the elephant. And this is due to the fact that these convolutions are applied at a sort of local level, and they don't maybe take into consideration the whole structure of the image and what it means to be a complete elephant that kind of makes sense. But nevertheless, they have been successful because images have this kind of local structure. So this is sort of the wider point, is that you kind of have to think about what the structure in the data is and then specialize the architecture to it. But they're also useful not just for images, but for, again, anything that has this kind of structure. And audio also has maybe phonemes and constituent parts that have sort of a local structure that you can pick up by moving through the data set in these stepwise fashion. And time series also have this kind of structure depending on the time series. Another important operations, this again introduced in the 90s and hugely successful more for natural language processing here. And it's this forget gate that has been used in these long short-term memory networks, these recurrent networks that have been applied to sequence data, so stuff like time series again, but also languages that come in an ordered fashion. And here it turned out that you don't want to keep representations that store all the information that you've seen so far, but that forgetting information is just as important as keeping everything around, because not everything is relevant. Some things are noisy, some things are distracting. And if you want to get at the sense of a sentence, you might want to only attend to some pieces of information, but not others. And this has turned out to be hugely successful, and especially for translation, all of the systems up until a couple of years ago, Google Translate, were using these long short-term memory networks, and they had a huge success also in deployment in mobile devices and so on, and they've been very influential. Now we've just shifted, and there's sort of a shift both in the research field and in the deployment of these systems to these attention-based networks. You might have heard of transformers, these huge networks with billions of parameters trained by OpenAI, Microsoft, and everybody's sort of flocking to the latest bandwagon. And here it's sort of the same thing, right? So attention means that you are focusing on some element and thereby discarding some others. So it's, again, to some extent about forgetting. It's just achieved in a different manner. And here the example is with images, and you can kind of see that so there is a highlighted word, and this is sort of like the query, and then the network will pick up where it should focus, where it should look at in the image to make sure that you either you generate it correctly or you get the sense of what's happening in the scene. But this has been useful for natural language processing and sentence generation as well, and translation. So now the new systems are actually using attention more and more rather than these forgetting gates. And so again, here, this is somewhat more general than a convolution, because everything kind of requires some level of attention and looking at some parts of the data set more than others. But here, again, we're kind of doing this at a relatively shallow level. We're just saying some things are relevant, some things aren't. Try to learn where to attend so that you can get the sense of what is happening in the particular data set. And this is sort of context dependent. Another thing, that this is not a particular operation. This is maybe going at the fact that we we need to specialize to the data set in particular, and sometimes data comes in a very specific format. We shouldn't discard that structure. So maybe things are a time series, but maybe they actually come as a graph. And a lot of real-world data sets are naturally graphs. So for instance, social networks come as graph, but molecules also come as graphs. And we don't want to discard that structure because presumably it captures something very crucial about the data itself. So what do? We create, in this case, neural networks, but there's other approaches as well, that work directly on graphs. And you can think of these as somehow generalizing the operations that we looked at before, like attention and convolutions, to graphs in particular. And so this is just saying, again, think about the data and the kind of structure that you think it has. Okay, so hopefully this has already told about a few successes. We can go into when does it fail, and I think this is especially important in demystifying AI, to sort of say maybe not everything is worth investing in and not everything is worth believing, because it can be also damaging to the reputation of the field. So I want to make sure that we also point out the shortcomings. One example is this IBM Watson for oncology, which was a very ambitious project, which was, I guess, launched on the back of the success of IBM Watson playing Jeopardy, where a huge source of, a huge repository of knowledge in the form of medicine textbooks and data sets was mined to try to effectively cure cancer. And it turns out, so it seems that it's controversial, obviously. It's not clear how much of a shortcoming or a failure it was, but it certainly was a very ambitious task, and it seems that it hasn't maybe delivered as much as we'd hoped. And I think the crucial learning points here are that, in general, if you're trying to pick up correlations in language and you have a huge data set, it's fine. When you're really trying to get a deep understanding of complicated knowledge bases, and obviously cancer is complicated enough that we also as humans don't understand everything that's going on, the machine learning technology of right now is just not cut for it. So here I would say that we kind of struggle with representing highly specialized knowledge bases, and there's a lot of interacting things that require to sort of go at higher and higher level of abstractions that it's hard to supervise, and it's hard for a network to pick up on automatically. Another example, a little bit more contrived, less significant maybe than not being able to solve cancer, is just the simple Sudoku. And there's been some progress on this. There's people working on this, obviously, in academia. But again, here it sort of maybe speaks to something that's complementary to the cancer case. Here, we maybe don't have many sort of a rich semantic structure. It's just a simple set of rules that you should sort of put numbers in cells without duplicating numbers. But actually, this is something that's very hard for neural networks and machine learning in general to do, because you have to learn a somewhat sophisticated set of rules just from a few examples. And okay, yeah, if I give you all the possible games of Sudoku, then eventually a big enough neural network can memorize it, can just learn it. But that's not very satisfying because it's just memorized. It hasn't actually learned to generalize. And learning is about being able to generalize to new examples. So here the problem is that we can't learn complicated rules from a few examples. And here it's also difficult to even tell a network what it is to be a cell or a number and what kind of relations we have to fulfill between these objects. So it doesn't actually work at a conceptual level. And this lack of conceptual understanding is a problem both for semantic understanding in the case of complicated domains like cancer, but also in more rule-based systems. And here a slightly different failure mode maybe is that this is more on a societal level. If your data set is biased and your analysis is not done correctly and you don't take into account, for instance, causality or sensitive attributes, you can go very wrong. So this example was a piece of investigative journalism by ProPublica done in the States, where this software company shipped out this software that was able to apparently determine the risk of recidivism in people that were undergoing trial, and it turned out to be very biased based on race, where people that actually in the end turned out to not have any subsequent offenses were deemed much more high risk purely based on race. And so here it's crucial to make sure that we also are wary of the application of AI, and that simply maximizing some simple objective function like accuracy is not enough to actually give you the system that you care about in the real world. And things like causality are a way to make sure that, for instance, presumably we don't think that race actually influences your likelihood of recidivism. So I think this is important in this case as a potential solution to these problems. And so just to talk about the things that I think are more exciting, based on both where the technology is at right now and what the trajectory is one thing is robotics. So robotics traditionally has been mostly highly engineered. All the success that we have in robotics in terms of assembly line, and also you might have seen Boston Dynamics, those are very highly engineered systems that don't actually perform any learning. So they're not basing their final behavior on experience. There's a team of humans injecting the intelligence in the robot. And it seems right now, and this is a video by Covariant, a startup that's now actually being pretty successful at solving some real world complicated tasks, like sorting light bulbs on an assembly line. We are at a stage where the machine perception, so the vision and the maybe even sound processing, are advanced enough to be fed into a system of reinforcement learning, which is basically the part of machine learning that deals with rewards and punishment and learning from those, that we can hope to have more flexible robots that complement, that maybe take out some of the parts in the assembly line that are still needing a lot of human supervision. And so this is something that is starting to happen right now, and we're seeing actual learning robots in the assembly line as well. And another very exciting frontier is healthcare, obviously. I'm sure this doesn't need too much explanation. Everybody's thinking about it, especially from the diagnostic side, where images obviously make a huge part of healthcare, and machine learning is successful at dealing with them. So it stands to reason that we're going to be able to use machine learning for diagnostics in case of, like, for instance, MRI images, X-rays, and so on, detecting cancers. And in some of these domains, there's already things that have been approved by health regulation bodies, and they've surpassed human accuracy. But also drug development, for instance, going back to graph neural networks, that's something that could potentially be used and leveraged for doing drug development, and it's something that is going to see a lot of companies have already started to invest heavily in. And finally, there's going to be, I think, second-order effects that by collecting all of this data and putting this into the models, just like doing even standard statistics, we're going to be able to model health outcomes and generally get a better understanding of the patterns that regulate human health. And so in summary, I think it's important to always think about the structure of the data and how it can be exploited by the machine learning architecture and the tools that we're using. And so there needs to be a high level of specialization. We're not at the stage where we can just throw a general intelligence at a problem and expect it to be solved by this intelligence. There still needs to be at least the sort of meta learning of picking an architecture specialized to the problem. And just highlighting the failure modes again, if the data is very semantically rich, for instance, creative content, or in the case of like a knowledge body of the whole field like medicine, or it follows strict complex rules, current ML, at least based on neural networks, naive neural networks will struggle. But this is one of the most active areas of research, so hopefully this is going to be solved pretty soon. Thank you.
Thank you, Ale. Now it's Charlie. Just the other way. There we go.
Great. Thanks very much. So Matilda's talked about the investment for the potential analysis, and Alessandro has talked about the technology. And I'm going to try and talk about how an industry might respond. And what I'm going to be talking about is very much drawn upon the research that I've done about media, as I mentioned, and of course this latest project that we're doing looking at journalism and AI. And I have to say, it's great to be here, partly because journalism, just like any other industry, is very prone to siloed thinking. And it's great to have these conversations over the years with people like Matilda and Alessandro to sort of get us out of our cultural box, as it were. First, though, I'd say let's sort of step back a little bit to the bigger picture. This is a piece of work that I did in 2018. I led the LSE's Truth, Trust and Technology Commission, which was an investigation into the whole information crisis. And the point I'm trying to make here is that we're talking about a world that has changed enormously. It's changed partly because of technology, but also, of course, because of social, political trends as well. And of course, you know, we can see how information has changed in fantastic ways that creates opportunities for enterprise and public value, but at the same time, there are these downsides. Alessandro mentioned some of the sort of mistakes, if you like, that AI can make and the biases that it can have, but also some of the bad actors that use it, you know, with fake news, for example. But the key point is the world is very different. And I think as citizens, as governments, but also as businesses, we are struggling to cope with that. There are all sorts of interesting gaps, but we're working out how we can actually address some of the problems that we think technology might be applied to. Now, the critical role of AI was very apparent to me when we're looking at journalism. It's why we decided to do the report on new powers and new responsibilities last year. We talked to about 100 news organisations in workshops and surveys and so on around the world. And we asked them what they were doing with artificial intelligence. We asked them about the challenges and opportunities and the future changes that it was going to bring. And incidentally, that's led to the creation of the Polis Journalism AI Network. And what they made clear, and it's no surprise after Alessandro's presentation, what they made clear was that this is very, very complex and that its impact is definitely tangible, it's already happening, but it's not really going to have a deeply significant impact for perhaps 3 to 5 years. So this is what the media practitioners told us about that kind of impact. And having looked at studies of other industries, I think many of these ideas are very replicable. The first point they stressed is that AI has an impact on all aspects of news production, news media. It impacts on news gathering, on news production, and critically, the bit about distribution, marketing, consumption as well. And they are all somehow interrelated. It has the function of replacing journalistic labour. So automation at scale, for example, is incredibly efficient. A company like Bloomberg, I think it's like 30–40% of much of the content they create is now done pretty automatically. For example, company reports. They stress very much that the AI augments existing human practices. So things like data investigations, you know, the Panama Papers, could not have happened without AI technologies. Then they also stress very much that this is making journalists and other people in news organisations much more efficient and effective. Even quite sort of mundane-ish sounding things like transcription and translation is making journalists much more effective and making their content much more effective as well. And finally, this is a sort of intriguing point that you don't just introduce this stuff, it changes what you do and how you work. So one small example would be around job roles. A few weeks ago I saw an advertisement for a news media organisation for an algorithms editor. You know. And obviously in terms of the user, the personalisation, the effect that has on revenue is really important. So journalism is a weird culture. It has a particular mission. You know, we like to think we're very important for things like democracy. But it's also a relatively small sector. And it's, of course, as you may know, it's struggling to create a business model that works. But I think the impacts that it describes are recognisable in other sectors, especially the downsides, the cultural barriers that you face trying to introduce AI, the huge knowledge deficits within your sector, and of course, and this is the bit that Matilda's talking about, the limits on investment. So I think it's important to think about what's different about AI, And it is clear that journalism has been, like a lot of industries, has been through two massive leaps recently. There was the big move online. Everyone got a website. Hooray. And then there was the second huge transformational thing of journalism going on to social media. And AI is different in lots of different ways. Data, as you know, is a key resource material. And of course, all sectors have got special needs and sources for that data. Well, journalism already uses a lot of data. And journalists are pretty skilled at understanding and making stories out of that data. But it doesn't have enough, and it probably doesn't know how to handle AI data, certainly at scale. Knowledge and skills are going to be absolutely key. News media needs much better understanding of AI and AI competencies right across the board, management, marketing, as well as the journalists. And the news media does have a lot of very smart people in it, honestly, but not many AI specialists, and or people, more importantly perhaps, who can actually relate the AI to journalism itself. Building tools for new services, as Alessandro again has hinted at, is going to be complex and difficult. As Matty said, the platforms are critical, but there is a huge craving out there. It's something that surprised me actually. A huge craving out there in the industry for tools that are relevant and effective. And that's because people have discovered that it really takes time and iterations to make AI work. Not just the time for developing it, but for the actual implementation and review of those processes. And the problem, especially for journalism, is that the R&D resources are very unevenly spread. The tech companies, perhaps the major corporations, have the assets, but the industry as a whole has a lot of inequalities around research, and it desperately needs to find new ways of developing products and systems. I mean, the good news in a way is this graph, which shows that there has been this huge increase in AI investment by corporates. The last graph is only halfway through 2019, so it's obviously an upward curve. If you're in media, perhaps slightly less impressive, with a tiny little thin pink bit at the bottom there, but still increasing. So how do you think about, if you like, in a sense, how you can attract that money to your sector? And I think it's really important that you think strategically about this. One of the ways is around new roles and systems, that your own organisation has to be, if you like, AI ready or AI adaptable. Another thing that surprised me was the second one about collaboration. The news organisations who are famously competitive and insular were really interested in working with other people, even with other news organisations, but especially with people who know, people like universities, where people like Ale work. And of course they know they're going to have to work with the tech companies. Quick reminder, my research, sponsored by Google, of course. They know they're major players. But the big message, again, somewhat surprised me, that there's a real interest in what I'm calling opportunities to work with intermediaries, referring to that vertical idea that Matilda talked about, people working on particular tools in particularly nimble ways, for example, startups. And a really good example of this, it's on the Polis blog, was a recent live experiment carried out in Finland, where a research startup worked with a major media company to develop a universal language model which helped predict what kind of content would be most effective in getting users to subscribe to the news service, which is absolutely gold dust for news media. So to end, I think only VCs who are particularly focused on the unique character of AI can deliver that kind of innovation that sectors require. AI is a really key priority. It is not going to save my industry, the news media, but I think it will be critical. And like every industry, whether we like it or not, we are going to be living in a data-driven, algorithmically shaped world. And we need to have much more fresh thinking about what we invest in and who we do that with. And as I mentioned, we're working on these kind of issues around our journalism AI project, but it's been really inspiring and stimulating to work with people like these guys who can bring us a kind of informed perspective from outside of my industry in a way that I hope can be transformational. Thanks.
Thanks, Tim.
I think my challenge is to convince people to invest in startups through AI. I'll do my best. My talk's really split into two halves. One is to tell you about the business, and the other is in what we do, so you get a bit of an understanding of it. The other is to tell you sort of how the AI effectively works underneath it. But there's a kind of a cautionary tale as well with it, so I want to try and give you the what's and all, if I can, behind the scenes, the difficulties and challenges for the startup. And I'm going to give you the answer, or the conclusion of the talk straight away, which is always the best way to start, isn't it? But AI is really just a tool, and what you should be doing when you're looking at what you're going to invest in is looking at it from a product market fit perspective all the time. What problem is it actually solving? Is it a big enough problem? Is it a valuable enough problem, basically? That's the ultimate conclusion. So I keep ultimately, when we sat back, my background was at Shazam. A lot of my career over the past 20 years has been in search and understanding content and being able to surface that content at the right moment for people. While I was at Google, we came up with the idea to create some kind of Shazam for business. It's the best way we can kind of describe it. And what this is essentially we created a horizontal conversational platform. It's not a bot. It's something that's able to create self-service from business knowledge, wherever that is in the business, in a way that you can dialogue to, right? And we've got sort of essentially 4 different focus areas. One is direct to the customer. You'll come across bots and things like that. The other is agent assist. So British Gas is an example of this. They use our service to be able to kind of augment the agents when they're answering customer questions by giving them the answers and giving them all their tools and automation and things like that directly at their fingertips. Also employees, imagine if you had a contract and you could talk to your contract and get the answers from that contract rather than going and searching through your SharePoint or whatever it is that's causing you pain currently. And also business analysts. So one of the key challenges when it comes to self-service is sort of understanding what it is, what knowledge it is you need to create, right? So what are the use cases in your knowledge? Where do you even begin when you're going to create knowledge for your customer service? So we built a platform that's able to solve a lot of these sort of problems and challenges. There are sort of some success rates on here effectively that you can see. I won't talk too much about that because we've got a certain amount of time and I want to get through this. So really the problem that we're solving here is that there is no simple or effective way to manage conversational self-service to business critical functions. So over the past 3 or 4 years, everyone's raved about bots and now everyone's kind of not raving about bots so much because it doesn't work as well as everyone thought they would. You've got voice assistants and things like that. And one of the big problems with that is the fact that you're building a new knowledge base, you're configuring these bots behind the scenes. And if you've ever tried to configure a bot, which you probably haven't, it's really difficult. You have to build these decision trees. If you use Google's dialogue flow, you have to build these question, answer. You need to know what it is you're building as well up front, so you've got to know all the use cases. So, a lot of things fail with bots today. So we set out to build something that kind of gets over these problems and actually fulfills this sort of a vision of self-service where you can actually automate knowledge. And now, we don't want to automate everything. We believe that humans are really important. That's why we also sort of support agents. Companies like British Gas, that's massively important. But we want to automate enough to take a lot of the pain away and to be able to get into the sort of deep knowledge that a lot of these companies and businesses have that's sort of tucked away, that's so important to the running of these businesses. So that we can help you sort of get your head around that. So that's what we do. The system that we built is quite sort of complex, but it's simple on the outside, and that's one of the challenges that we had to overcome. So the system's able to predict, we're able to ingest a lot of historical data, tell a company actually what all their use cases are up front, and tell them how successful the system can be before it starts being used. And that's really important because suddenly they've got something they can sort of check us on at every step of the way. and we're able to then sort of they're able to hold us to that, and we're able to deliver on how successful it can be if they sign up. It's able to retrieve the knowledge very quickly. It can create conversation directly from the knowledge. Now it doesn't change your knowledge. What it does is it's able to structure those decision trees for you and predict them, which is a little bit different. And it's able to automate all the tools and workflows that you have, which is what we start to do with GATS. And then it knows when to escalate when it really doesn't know the answer. So, and actually being able to say no is actually quite a difficult problem to solve, bizarrely. And then it's able to sort of maintain the knowledge as the knowledge goes out of sync with the product and new products are launched and things like that. There's a bit of a comparison at the bottom there. Here's a very quick demo on the most basic level of it. So we took Spotify. If you look down here, we added Spotify support. We didn't add any knowledge. It automatically sucks in the website, Spotify's website. And then you're able to very quickly sort of set up a widget, which is there. You don't have to. It's an API-based platform as well, so you can integrate directly into whatever you've currently got. You're able to then put it on Spotify's websites, which I'll show you, like this, very quickly. And then what it's able to do once it's on there is you're immediately able to start asking it questions on the knowledge that it's sucked in. So there'll be a question here that we're able to show you. And it's able to sort of surgically find the right answer in the knowledge, and you're able to start to talk to it. So you'll see there's a couple of options for the question, and it starts to pull up the answer. A couple of examples. So Aegon discovered 35 new use cases for them that they didn't know existed in their data, so that was really, really powerful for them. British Gas was an interesting one. They didn't realise that their agents didn't have 85% of the knowledge they needed within this particular segment of British Gas, which is was a real surprise for them, but also something that was very valuable in terms of what the system could do for them. We were able to fill that and be able to stay on top of it for them, so that was very powerful. Very specific example here, just to give you a sense of what the technology can do. So if you ask a question, I'm having issues with my laptop, for example, you'll get a certain number of options. What you don't want to do, which is the classic thing with bots, is to ask a different questions, like the one at the end there, Windows is frozen, and get the same answer, which most bots will do. This is able to navigate the decision tree all the way down and pull the right answer at the right point. So switching very quickly to talk about sort of the AI, the ML underneath. This is a sort of a progression of how we effectively implement the service. I think what's more interesting is, this is kind of a bit of a 101 if you're starting a startup on how to create an AI business. So AI as a service, if you like. So you need your problem. You need to get clean annotated data, as we were saying earlier in one of the conversations. If the data is slightly corrupted or is not clean, you're going to get a biased result or no result at all. Then you're going to be able to train the algorithm, and then this is one of the key things that when you're looking at a very early stage company, you have to make sure that it scales. And a lot of people don't look at that, and it can become very expensive very quickly. When you're actually trying to scale and stuff. So you need to make sure that is able to scale, and then you've got a trained predictive model. After that, then this is kind of how it fits into our stack, into our product, if you like. So you've got your traditional sort of front end, the interface that you might use. Then you've got whatever the models are that you've trained and created. So that's sort of your IP that you're creating here. Then you need a data pipeline. So you need the data to be able to be being pushed directly in through those models out to the user, but you also need to be sort of capturing it as well. And effectively you've got AI-powered products. So what does this mean for us? Well, this is how it looks for us in that sort of same sort of setup. So on the front end, we've got a web widget, we've got APIs, it's hosted on Google Cloud, it could be AWS, it could be anything. Our back end is a sort of Golang, sort of Google language, and there's a web console for the ultimate user. But what's interesting is if you look at the AI sort of between brackets there, you can see that it's not one algorithm, it's a number of different algorithms. So when we talk about the fact that we have a company that is an AI sort of powered company, it's quite a complex set of algorithms, and the data pipeline, if you go along a little bit, is also very complex, to be able to make this work. But it scales, and it took a lot of time and pain and effort to be able to get it to scale cost effectively as well. Very hard to be able to index content cost effectively, and that's why when you use your search these days, it tends to be just the subjects, so the names of the documents and things like that, rather than what's in the documents. So finding a solution to that was also very difficult. So the IP is not just in the trained algorithms, it's in the data, it's also in the ability to scale it, as well. Two more slides for you. One is to give you a sense of where we fit into the landscape. So we're sort of AI as a service, if you like. So we'd be able to productize something and make it very simple. So these teams of data scientists to be able to use it. We focus on enterprise businesses, typically large to enterprise businesses. But you've also got this kind of, if you look below it, you've got the sort of two layers there. So you've got some various APIs that you can take off the shelf. So if you have a company coming in saying they've built up IBM Watson's technology and you want to invest in sort of IP and AI, then you'll be sort of investing in IBM's technology really. And the same sort of below that. And then you've got the basic toolkits and frameworks. So we actually use TensorFlow at the bottom as the open source framework to be able to train a lot of our algorithms off, basically. So final slide for you. So just a broad summary. So what are the negatives of sort of creating an AI first business? Well, something like this takes a lot longer. So when you're investing in it, it doesn't really fit the traditional investment startup model. It's going to take a bit longer, to be able to get out. They're going to have to raise a bit more money. Finding talent, Facebook's, Google, hiring a huge amount of engineers. They're hoovering up these engineers everywhere. So if someone's coming with a team, that's already built, then that's amazing. That's incredibly valuable in itself. It's quite hard to get the real talent out there. Sales cycles, enterprise sales cycles are insanely long, really painful. As a small startup, we would go through, and the first time you go through this is very difficult as well, right? So you've got to go through all the documentation. We haven't talked about data privacy and being able to anonymize data and things like that. We're asked to create data lakes in the cloud, the likes of Aegon and British Gas, where we flow our data off. We have to build all this stuff. And you have to try and make the choices where you can scale this stuff, so you're not building custom every time, because then you're not an AI product, you're effectively a consultancy. So the danger is you become a consultancy, so you have to be really careful about that. Positives, you've got the innovation, you're building hopefully a really nice big iceberg of protection that people are not going to be able to compete with you on. A lot of people ask us, well, why don't IBM or Google or do this? Why aren't they doing it? And the truth is, we come into direct pitches with the IBM Watsons of this world, and we typically win most of the time. And it's because we're insanely focused on just this area of self-service. So we're able to beat them because they have this broad focus. Enterprise SaaS, when moving, is incredibly valuable. So once you've got these customers going, it's amazing. These contracts are long, you get paid up front, it's fantastic for cash flow. It's incredibly difficult to get it to that stage to make sure this stuff is working. So you need to have enough money in the bank to be able to get there. So ultimately, key points, AI is a tool, not a product. Use it wisely. If you don't need to use it, don't, because you don't want to sort of crack an egg with a sledgehammer. AI first businesses require longer and more investments, and ultimately learn how to protect the IP. It's very interesting. When I was at Google, I became friends with the head of IP at Google, who was also called Tim Porter, interestingly. So it's one of my first emails I sent him. He got Tim Porter at Google. So he'll be getting some of my emails, and we have to exchange them, and we became friends. But the point is he gave me a lecture on protecting IP, which is amazing for him to do it, but it helped me to understand how to protect it, where to protect it, and how to do it cost effectively. And when also as well, because you don't want to spend your time and money at an early stage doing that if it's not necessary. And the value is ultimately in the data. Having remote valuable data that is being created is incredibly valuable.
Thank you. Great. So I think we have time for a few questions from the audience. Cool. Can you introduce yourself? Sorry, just before so we get to me.
I'm Margherita Marini, working for UCL Innovation and leading on high-growth SMEs consultancy and working with spin-outs. So I have a question for you, Matilda, actually. Well, first of all, thank you for organizing. I think most of us work in really busy, we never take the time to reflect
On Mondays especially.
opportunities and challenges. So it was good to take this time, and it was really interesting to reflect on these things. But I was wondering, going back to the investment side, how do you at Hambro Perks organize and sort of get your deal flow
The companies.
ready?
Yeah, I think first of all, each one of us is really specialized on one sector or two sectors maximum. So like George specializes in fintech, I do AI and machine learning primarily. And this basically allows us to, first of all, kind of recognize between good and bad, because if you constantly see like many different companies doing kind of the same thing, even if in different verticals, you start to recognize that. And second, it's really built on the network that you have, right? Because I worked in machine learning basically my whole career, I have a very good network of people that start companies. So I would say that kind of 20% of my deal flow comes from my own personal network. Then obviously 25% I would say probably comes from people that I know, like Charlie and Alessandro, that are really linked with like universities and also other founders. And then 25 probably for people like Team actually, our founders themselves, kind of recommending great products and new companies. And then the rest is kind of outreach actually. Like for example, we're doing I'm doing a big deep dive on the future of work. And so one thing that we really do is just reaching out to companies that we think are amazing. So also outreach directly, it's really good. So that's kind of the breakdown, if it makes sense. Cool.
Great, I have a question for Tim. Really interested to hear. I'd like to hear your thoughts on how you protect the IP. If I understood it correctly, you built your own networks from the ground up. So you're not using someone else's frameworks, such as Google Deception or any of those frameworks. How do you go about protecting your IP? How do you keep it safe?
It's a great question. Ultimately we do patent the things that we think are the most valuable. We just had some great recommendations for patent lawyers in the US that do it at a very cost-effective rate, basically. So that's one thing. But on the most basic level, if you don't have the cash to be able to do that, then it's about knowing what to disclose versus not. Ultimately, it's not overly complex. Obviously, when you're going through better funding, you have to be upfront to show what you have, and that's fine. But in terms of what you talk about and the level of detail that you talk on, we did a talk at a conference in Switzerland 2 or 3 weeks ago that was machine learning focused. You have to be able to talk at just the right level, not to be able to give away how you do it, basically.
Just one question, because we also have a patent for some of the work that we do and how we approach it. But it's effectively a roadmap to replicate some of the work that we've done, because the field moves so quickly. You can't get a broad enough patent to protect it. So when you're sort of deciding whether you're going to do it, are you thinking, well, if I give away just a little bit of how we approach our work, that's not going to give away too much background secrets?
You effectively get 18 months where no one will see it because it's going through, so you've got 18 months to be able to make something valuable from that particular patent before it's published. But you're right, there are some things you do have to be careful with, and if you think it's going to take longer than 18 months, then you don't do it.
Thanks.
Yeah, sorry.
Well, thank you very much to the panel for helping us, to those of us who have no clue about AI, to demystify AI. And the question is, I think it's very simple, but how far away are we from, and what is needed for AI to be really artificial and intelligent?
How do you want to take this one?
Yeah, it's a great question.
Can you give us a date?
Yeah, I think this time next year. No, I don't know. So I'm fairly cynical to some extent about artificial general intelligence. I think it's worth bearing in mind that the great majority of the field doesn't think about these things. Simply, at least in machine learning, right? So if you go to the big conferences, NeurIPS and ICML, it's very narrow, sort of the notion of AI that we work with is sort of doing good image classification, that kind of stuff. There are obviously, in a sense, maybe companies, so OpenAI and DeepMind are the ones that are more concerned with trying to actually tackle the full spectrum of of challenges simply because they can employ so many people that are working on so many facets of machine learning, and therefore they can think about putting those things together. In academia, people have to worry about publishing papers, so they'll pick the lower hanging fruit in the sense that they think they can make the most headway in. So yeah, you're not going to get me to give you a date, I'm sorry, but I think it's generally true that we have made a lot of progress in the various parts of, for instance, machine perception. So we've now at a stage where almost all our senses have been to some extent replicated at a proficient level in machine learning. And it stands to reason that with those tools, we can then build something that glues them together. However, so one thing that's interesting, for instance, is that in autonomous driving, which is maybe one of the applied things where most of the a lot of investment has gone, and a lot of manpower has gone behind it. The part that's kind of machine learning enabled is the perception side for the actual driving, which, and I guess, so autonomous driving is interesting because it is almost general. It's almost AI complete. You kind of need to solve so many problems to do it. But for the perception, you have machine learning, and for the actual driving, you have rule-based systems still, mostly. And there are companies that are trying to do everything kind of end-to-end from data, from experience, and learning it using reinforcement learning. But those are still very experimental, and it's also, I guess, a safety issue, right? We're not confident enough in that technology because it doesn't necessarily come with guarantees. So it's not always a question of technical proficiency, but also of how risk-prone you are, right? But I think generally there's good progress, and there's reasons to be optimistic about general intelligence. The problem is that it's hard to also define it, right? So it's also harder to measure progress compared to having a clear benchmark that you're kind of evaluating every year, and you can see the accuracy going up every year, right?
Just to add to that, in the sense that I think that we're at a really interesting stage. Obviously, it will vary from sector to sector, where at one level, the industry says to me, for example, well, I'd love it if you could really get translation right. So there is a technological incremental thing that you might do that will, when it gets to a certain level of proficiency, it's going to transform certain industries. When you think about news media and language, it's going to be transformational for many people, or at least catalytical. But generally speaking, the focus is much more firstly on how do you apply this, and as Tim has, I think it's a great case. It's however great your tech is, it's still, there's the human factor, there's the business factor, and also the thing we haven't got time for tonight, but there's what it's been mentioned actually by Ale about the ethical bit, and also of course regulation in every sense. So there's so much to be getting on with, and I think all that still doesn't mean there's fewer opportunities. Even before we get the big bang of AGI.
Any other question? Yeah.
For Tim, how do you actually price your product and your approach? How do you do that really
I would love to say there was an amazing scientific way we did it, but it's actually, it's trial and error. I think it's the best way I can say. You look at what's out there in the market, you try and benchmark it a little bit. You also look at what the ROI is on it, right? So for something like us, you can see they can measure the value of every ticket, in a business, so you start to understand that. So there is a little bit of calculation you can do, but then ultimately there's the intangible stuff in terms of how important it becomes to them when they start using it. So how do you price that in? It becomes very difficult. So ultimately, what we do is we calculate as much as we can, and then we go and pitch it and see if people are willing to sign up to it. If they sign up too quickly, you're going to get to and it's not, you can always change it. Every time you go into a new pitch, you can change it and adjust it accordingly. So there is a little bit of, a bit of back and forth. But just as a small anecdote, when I was at Apple, if you think pricing for startups is interesting. When we first sort of pricing the songs at iTunes, we didn't know either, really. How much it used to be 99p in the UK, if you remember. But so what we did was we used a can of Coke to cost of a can of Coke in every country, and used that as the way of validating the price. And pricing is a really interesting thing.
Last question, guys. Yes.
Good question for me. I think linked to pricing, but not so much the value of the product, but also the value of an AI company. So I think Alan and other people have mentioned that there hasn't been any major catastrophes yet for AI products, but I work on corporate partnerships with healthcare, funny enough also at UCO. It only takes one event to kill the field.
Yep.
So what happens tomorrow if an algorithm, for example, is found further down the line to be responsible because the diagnostic protocol is wrong or the drug pathway is wrong? The only field that I've heard of where AI plans for AI, like in ShowTech, to maybe change things is automotive vehicles.
Yeah.
So if an automotive vehicle crashes, it's a manufacturer. It's no longer you don't go to sure. So do you think that should be factored in? And question for Matt Field as well, too, in the valuation of the company?
That's a very good question. I mean, yeah, I think so. Liability is very complicated. In a sense, it's not really for the scientists to decide. I think this is one of those themes where it's good for the policymakers to be informed about machine learning, but it's an ethical question, right? It's tough to keep engineers personally accountable for the things that they develop. You don't want to stifle sort of productivity and research as well, right? If you tell me, Alessandro, if you develop this and you kill somebody, you're going to go to jail, I'll probably not work on healthcare, right? So I think, liability is a tricky one. Probably, I guess, for automotive, it's already happened, and healthcare, we're probably going to see more of that. I don't actually have a good answer. I think there probably needs to be, if I can speculate, I guess maybe there should be some governmental bodies that process and vet algorithms and kind of determine their safety. And this is something that is also maybe more of a technical question. So there should be, and there are processes that kind of determine the fairness of certain algorithms and the data sets. There's a lot of work around differential privacy, for instance, about protecting sensitive attributes, about causality, like we mentioned for the legal case. And so if you do take those things into consideration, you can make your systems a lot more robust. And going back to the valuation point, I think we're kind of seeing that some companies are starting to take bets and maybe take a slightly hit on profit or a slightly longer turnout for some of their products, but investing, for instance, in differential privacy. I think Apple, one example, where it seems like some of those bets are actually starting to pay off also in terms of shareholder value.
Nice. I think that's it. I really wanted to thank the panelists for being here. Really appreciate it, guys. And obviously the audience for being here. It's Monday, so it's double appreciated. And Hambro Perks for helping organize all of this event. So outside there are drinks, so we'll all see you there. Thank you very much.